So for this one, screen back on, you should use 2x minus 1 as your u. And then so the derivative of 2x minus 1 is just 2. You put the dx with it. And so you have your dx, but you don't have a number with it, so you've got to put that 2 right there, and the 1/2 has to go out front to balance that out. And so you can replace the 2x minus 1 with u, and you're going to replace the 2 dx with du, giving you 1/2 integral of the square root of u du. I went ahead and wrote that as u to the 1/2 just to make it a little bit easier for me to think about taking that integral. And so you increase your exponent by 1 to make it 3/2. You're going to divide out front by the 3/2. 1/2 times 2 over 3 is going to give you 1/3. And so you get 1/3 2x minus 1 to the 3/2 plus c. Okay, question. Okay there. Alright, so this is how we do just a basic problem. Here's our next problem. Okay, we have the integral of x times the square root of 2x minus 1 dx, which looks like it's just about the same problem. But you've got this x outside. So that is going to cause us some major problems, and it's going to make this much more expensive than it would be otherwise. So you still have to let 2x minus 1, you still have to let that be the u. You really don't have another choice of anything that could be u. If you use the whole square root of 2x minus 1, you'd end up with crazy stuff. Make it much worse. So u has to be 2x minus 1. So du is going to be 2 dx, just like in the last problem. And you can even do the same stuff we did on the last problem where we put the 2 here and the 1/2 out front. You can do that. And so you've got this part as u. You could take this 2 dx, you could replace it with du. But here is the problem. Whenever we substitute in, I've got 1/2 the integral of that x right there didn't get replaced. So I've got x square root, x times the square root of u du. And I can't integrate this with that x sitting right there. So in order for us to get this where we can integrate it, everything has to be in terms of u. So if you get something like this that happens, here's what you need to do. I have said that u equals 2x plus 1. All right. So if u equals 2x plus 1, if I subtract 1 from both sides, that's still equivalent. U minus 1 equals 2x. And if I divide by 2, then u minus 1 over 2 is going to equal x. Okay, so what I've done is I solved that equation for u. So this should still be true because I just rearranged the formula, right? Oh, sorry. It is supposed to be minus. Let's fix that. So 2x minus 1, and then we have to add 1, like that, plus, and then divide by 2. So we should get u plus 1 over 2. Thank you for catching that, Lakin. Alright, so x equals u plus 1 over 2. So I can take u plus 1 over 2, and I can plug it in for this x right here. So that's going to give me 1/2 the integral of u plus 1 over 2 times the square root of u. Alright, we still got problems, but at least everything's u. So this square root of u, it's like u over 1. Right? So that square root of u really is in the top. So I could think of it being like this. It's like, I'm going to write this as u to the 1/2 instead of square root of u. U to the 1/2 times u plus 1 over 2. And I could distribute that u to the 1/2. Here's something else I could do. This 2 in the denominator, it's really like I'm multiplying by 1/2. I could take it outside and put it with the 1/2 that's already there. So that would give me 1/4 integral of u to the, this has exponent of 1, so 1/2 plus 1 gives you 3/2 plus u to the 1/2. I'm going to stop for a minute there, tell me if you've got questions. Okay, any questions? All right, so now we can go ahead and integrate. And so we're going to have, now this is important here. I have been using that 1/4 like it's the coefficient, but because I've got two terms right here, that 1/4 I need to keep it outside because it's got to be distributed to both of the terms here. So I want to be careful with that. So I'm going to have u to the 5/2, and then I've got to divide by 5/2 out front. And I'll have u to the 3/2, and I've got to divide by 3/2 out front, and then I'm going to put a plus c over here on the end. And so 1 divided by 5/2 is just dividing fractions. You just have 1 times 2 over 5. You're just going to get 2/5. It just flips the fraction. So I've got 1/4 times 2/5 u to the 5/2 plus 2/3 u to the 3/2 plus c. And I could distribute this 1/4 right here. So I'd get 2 over 20, which is going to be 1/10, and u to the 5/2. And then here I'll get 2 over 12, which is going to be 1/6. U to the 3/2 plus c. The plus c, you can put it inside the parentheses or outside. If you put it inside of the brackets here, you got to distribute that 1/4 to it. And I was telling Destiny on her problem because it had 2 c's in it. If you have, c is an unknown number, right? So if we have 1/4 times c, which is an unknown number, that just gives us another unknown number, right? So whenever you have something where you might need to distribute to your c, or add something to your c, or subtract something to your c, you can still just call it c, because c is an unknown number. C plus 7 is still an unknown number. It doesn't matter what you call it there. So you can just, I could have put that c on the inside where it would have to be 1/4 c, but 1/4 c could just be c. So I just left it on the end out here. And then the last thing we've got to do is plug back in our 2x minus 1. So we'll do that, and we will be done. Okay, questions? So the problems look almost the same, but you go from being able to do it in just a couple lines to taking up several lines. So the homework, goes from being, half a page to a page and a half, or in Cameron's case, he might have to flip back over to the back of the page just a little bit on this one. These are going to be a little bit more extensive. Here's a new one. Actually, let's get this. Let's do this one. We might just do these two. Okay, so we got the integral of x over the square root of 3x plus 2. What do you guys think the u should be here? 3x plus 2 is correct. So u is going to equal 3x plus 2. So du is 3 times dx. And so the du part, all we need is put a 3 right here and a 1/3 out here. And so we can substitute some things in. Right here, for the 3x plus 2, that's our u. The 3 dx, that's our du. But we've still got this x up here in the top. And we can't do this problem until we have replaced that x. So, much like the last problem, we are going to have to take this u right here equals 3x plus 2, and we've got to solve that for x. So we're going to have u equals 3x plus 2, so we'll subtract 2 from both sides. So we've got u minus 2 equals 3x, and we will divide by 30. So x is u minus 2 over 3. So this part right here, that x, is u minus 2 over 3. Okay, questions? All right, so that leaves us with 1/3 integral of u minus 2 over 3 over the square root of u du. And so we can't integrate this right now with that complex fraction, so I'm going to make this square root of u over 1. And dividing fractions is easy as pie. Flip the second and multiply. So you got u minus 2 over 3 times 1 over. I'm going to write that as a u to the 1/2. I think it'll probably help us if we do that. And so that gives us u minus 2 over 3u to the 1/2 du. And it'll make life a little bit easier if we just take this 3 right here and pull it out front. Because you've only got one term in the bottom, so you could, this is the same as if I had 1/3 times u minus 2 over u to the 1/2. That would be the equivalent there. So I can just take that and put it out here. So that's going to give me 1/9 integral of u minus 2 over u to the 1/2. Now I still cannot integrate that because I've got a fraction. So what could I do at this point? You can use a negative exponent, or you can do a love connection here. So either one will work there. If you do a love connection, you are just taking, you've got u to the first power over u to the 1/2, so 1 minus 1/2 gives you u to the 1/2, and then 2 over u to the 1/2 is going to be 2u to the negative 1/2. Or we could have used that negative exponent u to the negative 1/2 times u minus 2 and distribute that, and that would still give us the same thing, u to the 1/2 minus 2, u to the negative 1/2. Okay, questions so far? All right, then we're finally to the point where we can integrate. So you got to add 1 to the exponent, so you get 3/2 right here. And we'll keep that 1/9 way out here, out front. And this is going to be 1 over 3/2, which is going to be 2/3. And then we will have u to the positive 1/2. And then we'll have to do 2 divided by 1/2 here. And so right here, 2 divided by 1/2, it's going to be 2 times 2 over 1, which is just going to give you 4. So we get minus 4 u to the 1/2 plus c. And then your last step is distribute that 1/9. So you get 2 over 27 u to the 3/2. I said last. We got one more step after this. And we'll have 4/9 u to the 1/2 plus c. And so 2 over 27 times, what was our u? It was 3x plus 2. 3x plus 2 to the 3/2 minus 4/9 times 3x plus 2 to the 1/2 plus c. Okay, questions? Okay, that is all we're going to do today for examples. I think it will give you what you need. Your homework for tonight is going to be page 342. We're going to do 63 through 70 all. But number 69 is going to be extra credit. And it will be worth 3 points on test. Now, 69 is odd. It's in the back of the book. So when I check your work, I'm not going to be checking to make sure you have to have the right answer. But if you just have the right answer, it will not get you the extra credit. You got to show the work of how you get to that one. So 69 is not required. You don't have to do that one, but it is extra credit. In fact, I might need to